Yes.
Applications of Pascal's law. Look, students, to understand the application of Pascal's law on the basic board level, uh, let me explain you first. Hydraulic lift. What?
Hydraulic lift.
Lift. You might have noticed, students, when you go for the car wash, or you find at the service station, the mighty vehicle is lifted up by a simple mighty vehicle is lifted up by a simple heavy that heavy machinery is lifted up by simple concept of hydraulic lift. How come? Look up. Wait. There is you can go please. There is this kind of U-shaped, you consider, and this is filled with liquid, right? This is filled with liquid. Its area of cross section is A1, and here we apply a force F1. What is pressure? P1 here, F1 upon A1. Clear? Now, here we have a heavy load we have to lift, say a car, say any vehicle. Its area of cross section is A2. Now the force acting here is F2. So what is pressure P2 here? F2 upon A2. According to Pascal's law, pressure is transmitted equally in all directions. Very simple it is. F1 upon A1 equal to F2 upon A2. This implies F2 equal to F1 upon A1 into A2. Do you know, students, what is F1? The applied force here. What is F2? The weight of the vehicle here. So do you know, students, just by applying a little force F1, by increasing the area of cross section A2, the little force F1 is converted into the force F2, right? Means F2 is proportional to area of cross section A2. So students, you can lift any heavy machinery by little effort. Suppose you apply here force of 2 Newton and you need here force of 200 Newton. Here area of cross section is 1 meter square. So how it can be 200 F2? F1 is what? 2 Newton. A1 area of cross section is 1 meter square. A2 you have to find. A2 is what? 200 by 2, that is 100 meter square. Simply by increasing the area of cross section, you have increased your efforts. The 2 Newton is 100 times increased, that is 200 Newton. Just by increasing the area. So you increase area with the same effort, you can increase the load lifting capacity. This is the principle of hydraulic lift. This is called Pascal's law, one of the applications. Similarly, students, you know you have hydraulic brakes. How? When you are driving the car or any vehicle, you pedal the brake, you basically push the liquid, and that liquid is communicating the pressure to the brake drums, and you find that the vehicle stops. That converts rolling friction into sliding friction. One more concept here I am going to explain in short. Brahma press, B-R-A-H-A-M-M-A, Brahma's press. What is Brahma's press? Brahma's press is basically used to compress the metal lumps. You all know that metals are malleable and ductile. Suppose you have a big lump of metal and you want to make it as a sheet. What you do is you create a very hard roof. Students, it's a simple concept, so I am not giving an extra edge to it. I'm concluding only in this. So now what I have done, this is a big metal lump, all right, which is malleable and ductile. So what I do is, there is a hard roof, it is a very strong concrete hard roof. When we press F1, this metal lump strikes here. Suppose right now I've told if it is 2 Newton, you can make it to strike with 100 times 200 Newton, right? By increasing the area A2 point. Now when this metal lump strikes with a hard roof, then it gets pressed. And later stage it is converted into a thin sheet. By time and again, when you keep on pressing with the hard roof, it's getting more and more plain, and you can convert this irregular shaped metallic lump as a plain sheet. So this was another application of the Pascal's law. Brahma press, I've told here, hydraulic lift. These two questions are very, very important for the board level examinations, and you can also read it from your textbooks or NCERT, hydraulic brakes, which is an application of this. I hope it is clear.
Yes.